Okay, our next speaker is going to be Jim Cantrell. I'm going to introduce him because he's someone I've known for a long time. I guess I first met Jim in the late 1980s while I was working at the Martin Company, and we were interested in doing a Mars balloon mission. And Jim was actually working with Jacques Plumont and the French balloon mission that was going to accompany the Soviet Mars 1994 probe. In fact, he came over there, and we had heard that there was some problems with there, and are they really going to launch in 94? And Jim says they're absolutely committed to launching in 94. And I say, why? He says they're not sure if the Soviet Union is going to exist in 96. And we laughed at that, but in fact, didn't exist in 94 either. But anyway, then later on, we were working on our own balloon mission. He was working with me on the so-called Mars aerial platform mission. It's actually discussed a little bit in the case for Mars super pressure balloon mission. So we worked together on that. And then what happened was, so I got to know him. In 2001, Elon Musk came around the Mars Society because we had proposed the Translife mission to launch a spinning capsule into orbit with a crew of mice in it that would live in Mars gravity, and we could see how mammals from Earth could thrive in Mars gravity, how their children born in Mars gravity would develop. And Musk was interested in funding that. He actually joined the board of the Mars Society for a while, but he wanted a technical expert to advise him. So I hooked him up with Jim Cantrell, whose particular expertise was in the area of a small spacecraft especially. And also he had a lot of contacts in Russia, and that's where the cheapest launch vehicles were. So the two of them went over to Russia together to go shopping for launch vehicles, but all the Russians they met were crooks and wanted all kinds of money just to tell them an estimate of the cost or whatever, and Musk wasn't having any. And Jim advised him, look, you need to start your own launch company. Okay. And he was there. So Jim Cantrell had a key role in making SpaceX happen. And so and then he was there for a while, or an early period, I think around 18 months or so, and then he went off and started his own company, Vector Launch, a small satellite launcher. So it's my great pleasure to introduce Jim Cantrell.
Wow, Bob, that's a great intro. I wasn't expecting that, and I wasn't expecting to see my old friend Jim French sitting here in the front row too. So it's been many years. Yes. Jim was also involved in those early crazy days, and there was a guy named Lou Friedman, who some of you probably know, the Planetary Society. By the way, I'm writing a book called Breaking All the Rules that I go into all these sort of personal details about how this all came together. So hopefully early next year it'll get published. So I got a publisher finally. So a little bit sort of about my view of life. I'm really a car guy, and I got drug into the space industry by Frank Red, who started the SmallSat conference in college, and he had some crazy NASA money to do a study on a Mars rover, and I thought the idea of building cars on Mars was a great idea. So I got into it, and then all of this happened. So I think of things in terms of a transportation system. So what I'm going to talk to you about a little bit here is what I really consider as rockets as part of the transportation system, and why I think that it's changed suddenly, and what I think the future really is. Besides, SpaceX obviously has a big part of it. So with that, I'll just jump into it. Next slide, please. So this is New York City at the end of the 19th century, and if you look at it, it's very, very short in height. And if you think about it for a few minutes, and if you've ever been in New York City when there's no electricity and hoofed it up the 19 or 40 flights of stairs, you begin to appreciate the fact that going more than 4 or 5 flights of stairs without any machinery is really difficult. So New York City was really limited until recently. Next slide, please. If you look at it today, we all know, and I'm sure all of us have either seen it or been there, 80, 90 stories is not too unusual to see. And so what really made this happen was a new technology called elevators. And what elevators did was they expanded the real estate of Manhattan vertically, and thus the economy of Manhattan vertically. And what we're going to see, and Bob rightly talks about good ideas, and it's a good idea to go explore. I'm a little bit more capitalistic in my thinking. I'm thinking, how do we go there and make money, right? How does the economy expand out? Because if you look at the settlement of the New World, it was the Bob Zubrans that came and settled the New World, and then it was the capitalists like me that followed and tried to make money. So that's kind of where my ideas are sitting. Next slide, please. There we go. So in my way of looking at the economy, the rockets are really the elevators of the space economy, and it's the transportation system that allow our terrestrial economy to expand into first Earth orbit and then later out into the solar system. And as has been pointed out rightly, there's a lot of resources out there, but more importantly for me, there's hope. There's hope for humanity out there. So we will always chase that, but it'll be the economy that follows quickly behind. Next slide, please. So here's where I really see space in the space economy going today. It's a very capital-intensive, slow industry that's very hardware-based. But if you look at where tech is today, I mean, I came here on a lift and this ride-sharing economy, and we all have these computers in our pockets. And when I went to college, I didn't even have my own computer, let alone carry one around my pocket. Today's tech economy is all software-based. And that is exactly where the space economy will and has to go to thrive. So in order to do that, there's a dynamic in the terrestrial tech economy that things happen quickly. They happen with very small amounts of capital. That's why we have such innovation, right? And it essentially provides access to a larger base of people who can innovate. And so when you want to talk about providing hope to humanity, giving humans and the average humans access to space to make money in space will drive the innovation in space dramatically. And rockets are, strangely enough, the key to making it happen. And it's the hard part to get there. Next slide, please. So what's happening today, and Bob talked a little bit about this, is what I call the microsat revolution. If you look at just not very long ago, 20 years ago, the standard was these rather large satellites like you see on the left that were costing hundreds of millions of dollars, were taking 3, 4, 5 years to develop. If you're NASA, maybe 10 years to develop. I just have to hit them a little bit. And if you look at where things are going, it's microsatellites. And I remember the first CubeSat I saw. Bob Twiggs, who was a hayseed professor from Idaho, came up with this little thing, and he was showing it to us at the SmallSat conference. I thought it was a toy. I thought it was useless. But it's turned into this huge economy. And today there are far more CubeSats being built than any other satellite and being flown. Next slide, please. So what you see if you trace the mass of each satellite with time, the data's on the horizontal, you start to see this proliferation of these, under 100 kilogram satellites and under 10 kilogram satellites especially. And we're starting to see these things really, which are picosatellites. I've been to Scotland and held in my hand a little satellite that was about as big as a can of Coke that is fully functional. So we don't know exactly where this will go, but what we can tell you is two things are going to happen. One, the small are going to continue to proliferate. The data shows it. And then number two is the big satellites are going to continue to be flown. Why, you may ask, would you fly big satellites? Well, most of them go up into places like geostationary orbit, where that's like real estate. It's like Waikiki real estate. You don't build a cottage on Waikiki. You build a skyscraper so you can put the maximum amount of people in and get your maximum return. Really, it's a scarcity of resource and space in geostationary orbit. So big launch vehicles have to service the big satellites, period. There's no argument about that. But then the question is, what services the small, and what's the best way to do that? Next slide. So when you start to look at what's really happening, these are some Planet satellites. I helped them raise their Series B financing. Just an amazing company that these guys came out of NASA Ames, and with some guys with some ideas, started literally in a garage like Apple. And they are now building hundreds of these satellites and flying them. I think the last count I saw was 350 satellites in orbit that they had put up there. I worked on Iridium, the phone system, And that was 100 satellites that cost $10 billion the first time around. The ones I worked on the second time around was $2.5 billion. It was cheaper. These guys are doing this for tens of millions of dollars. And so this just gives you a feel for the scale of the revolution as it's happening. Next slide. So when we talk about transportation systems, and I go to these transportation conferences, I was one in Germany a couple of weeks ago. This is normally what people talk about when they talk about the transportation system. It goes all the way from people walking on the street, micromobility, ships, public aircraft. But next slide. They always forget about the rocket. And so if you think about it, the rocket really is part of our transportation system, but it's a very immature part of it. It's not something that you can just go out and do. It takes a lot of money, it takes a lot of time, it takes special knowledge, right? Bob said that's why Elon talked to me. Well, I had some esoteric knowledge about the Soviet Union and their rockets, and that was the sort of thing that landed me this place in history with Elon, which I never really expected. So next. The thing to sort of keep in perspective is just until a few years ago, only nation states did this. And that was partly because of the capital expense required to do it and the intellectual capacity of the population. It took the best and the brightest to make this happen. And so naturally, this is where governments did it. There was also this business of wanting to put our payload on their target somewhere at the time of our choosing. And so national security came into factor on this. But as time has gone on, next slide, please, we found that private companies are doing this. And this is amazing in many aspects. I've written op-ed articles pointing out that the first Falcon 9 and the Dragon spent, I think Elon told me, $780 million of government capital. Okay, this was not privately raised capital. It was government capital to do that, whereas the Constellation program, at my last measure, was about $50 billion, and we barely got one capsule up, right? So a 50 to 1, 60 to 1 capital deployment efficiency ratio, this is a good bargain no matter where the capital comes from. So this capital efficiency and thus the speed to getting these things to work is really the great revolution. So the rockets themselves are better, but they're not the magnitude innovation that we see except in the financial side. Next. So large launch is hard. And even though SpaceX makes it look easy, this is hard stuff, right? And anybody that's tried to build rockets, who's blown engines up, I had a guy that worked for me at Vector, he was missing fingers, and I said, what happened? He goes, pump guy. And I said, okay. So stuff happens. I mean, these are energetically dense machines. They're simple, as Bob points out, and I made that same analogy. They're far less complicated than the average car that you all drove here in. But nonetheless, they're very hard, particularly when you get into large scales. Handling anything this big with that much explosive potential has its issues. Next, please. They're also capital intensive. So you just look at what it takes to even move an engine of this size, right? These are all specialized equipment and so forth. So to test it, to move it, to work on it, it's all very capital intensive. So large launch will always have its place, but it has its major drawbacks of mainly capital intensity and size and the logistics. Next. So this is a lot like the public transportation systems, particularly trains. If you're here in California, I know are always going back and forth on whether or not we're going to put a high-speed rail in the middle of the state, and so on. Texas is doing the same thing. But these are multi-billion-dollar investments, and in the same way, it's appropriate to think of rockets as much like the train systems. They require their own special infrastructure. They require a lot of sort of the cooperation of the public. In this case, they have to go through private land. When we launch big rockets, we have to launch around private people's homes. I've been involved with the guys out of Camden, Georgia, and there's 3 people on one island that are stopping them from getting the valid launch license there because the rockets fly over their heads. So there's a lot of analogies that draw together on these, but in the end, they happen because there's a great public need for them. Next. And there's always going to be a place for launching people. So if you launch people, you need a big rocket, no doubt about it. And so for the longest time, I would have companies like Boeing, Lockheed. They would. I was a consultant, and they would, especially in the early days when SpaceX was starting to have some success, they would they would ask me to come talk to them. And they would say, what in the hell is Elon Musk thinking? And I would tell them, even this was 10 years ago, I'd say he wants to go to Mars. And I knew this because when we were playing around with the Russians, he would pull out this little thing and he'd say, what do you think about this Mars-based design? And I'd say, Elon, put that away. That's like talking about aliens, right? You have a hard enough time selling what you're doing, building a rocket yourself, let alone talking about Mars bases. But as we see, he's right, and this has been his sole focus from the time being. So when I looked at Starship when it first came out, I was starting to float around the New York financial circles, and they would ask me, what the hell do you think he's doing? And I said, the only thing that makes sense to me is freight and human transportation on the Earth. Because getting stuff into space, this has so much capacity, there's not enough stuff to launch. And the idea of putting everybody's stuff on your rocket 2 times a year to get it into space is kind of a stupid idea from a lot of different angles. So it has to be about freight. And sure enough, if you do the calculations, you can see the cost per freight mile of putting this, say a payload from New York to Singapore is about the same as if you did it by freight. If there were some magic train, I know some politicians are talking about a train that goes over the ocean. If that really existed, it would be about the same cost in terms of per mile. So that's really what I see Starship as being, is mainly freight and human transportation. We'll have to wait and see what they're really doing with it, but that's what I predict next. So come back to the automobile, and we all have had experiences with the automobile. It's our personal form of transportation for most of us. Unless you live in New York City, most of us own or lease or have access to an automobile. And it's become a symbol of a lot of things in this culture, but one thing's perfectly clear is it's bespoke transportation, meaning that it's something that can take us in a tailored way when we want to go to where we want to go in the way we want to go. And this is once you get the cost of the automobile down, this then becomes a very, very powerful way of allowing another layer of the economy to happen. Next. So Henry Ford caught on to this. And those of you who don't know much about the auto industry, at the turn of the last century, the cars were like $8,000, $9,000 and then your dollars, and had to be operated by specialized chauffeurs. In fact, Mercedes-Benz predicted there would only be a market for 3,000 cars worldwide because that's how many trained individuals there were to operate them. And Henry Ford said nonsense, and his idea was to build a car that even his employees, who he paid a nice living wage, could afford to buy, and therefore revolutionized the way that cars were used. And as we can see today, Henry Ford really changed the landscape of our civilization. Next. And the way this happened was just simple mass production. It's strange from where we stand today to think that mass production really didn't apply to cars back then, but they made cars much like they made wagons. It was very much the same industry, cottage industry, that made wagons and cars, and they were all done by hand. They were individual designs and so forth. But Henry Ford put in this idea of an assembly line and mass production, very simple, and was able to produce these cars for $300 to $400 each. Next. So this is really what's behind the micro launcher, next generation micro launchers, is the same motivation that drove the auto industry, which is individualized transportation. And their Rocket Lab has done a great job. I helped them on their Series B, even though they get mad when I say that. And been over there. It's a great group. You've got Virgin Orbit, who's chasing what Orbital's done for many years, but in hopefully a lot less expensive way. We gave a crack at it at Vector. There's a lot of others out there. But this whole motivation for small launch vehicles is really based in some economic realities that most people don't really think about. Next slide. So there's competing approaches. So we talked about reusability of large vehicles, and we're talking about mass-produced small vehicles. Those really represent sort of two ends of the spectrum of competing economic models. Here's another thing that SpaceX gets mad at me when I say, there's whole pages on Reddit about me that they yell at me. But I've made the statement that the reason that reusability was brought in on Falcon 9, besides being a Mars technology, Mars landing and takeoff technology, it got the flight rates up of these large boosters that they had difficulty producing more of. So by getting your flight rates up, you amortize your cost of your standing Army and your very expensive infrastructure. Anybody ever been to Cape Canaveral? I was just there yesterday, and the pads and such out there are very expensive for these rockets to put together. And so the more you amortize that over more flights, the cost comes down. And so you look at SpaceX, and I think last year they did somewhere around 20 flights. I don't know how many this year they're up to, but that's really the motivation for reusability in my book. If and I know Jim French would back me up on this. When we did the classic calculations of what's the payback period on a reusable vehicle, it comes at about 5 to 10 reflights of the same vehicle. And so when SpaceX brags about 2 or 3, that's a great accomplishment, but you're not recovering that non-recurring engineering that you put into it. So where the motivation is again to get the cost down through the flight rates going up. On the other hand, when you build a lot of something, it's hard to imagine if you're not part of the industry, how much the costs come down. So anybody have an idea of how much a first unit car costs a car company like GM? Is it 50 million? Anybody say 50 million, 20 million, 10 million? It's about $100 million. So by the time that car gets to your dealer, it's typically in the $30,000, $40,000, $50,000 range. And that's because they're producing millions of these things. There's this effect called the learning curve. So with the cumulative production, if you have the discipline to produce the same thing, which in the space industry we don't, okay? That's one of the big issues, is the engineers want to fiddle with every damn one of these things that goes out. And I know the SpaceX complains about this too. Some of the guys I've hired from SpaceX say, oh yeah, every third vehicle is a different one. And everybody wants to fiddle with it, make it better. That's sort of in our DNA as engineers. But if you have the discipline to manufacture the same thing over and over, you can get real cost savings. That's why airplanes are still in a reasonable amount of money to they're not produced in huge numbers, but they're at least not $100 million for a Cessna. Next. So what happens too when you go small is there's a nonlinear reduction in the costs, the cost of the infrastructure, the cost of operating, the cost of building, and the cost of developing. And so if you look all the way from the SLS, I call it the rocket to nowhere. And I interviewed, I'll just tell you guys, I interviewed at NASA for the number 3 slot, and I think I killed myself when I said I didn't like the SLS. So that lost me the job, but that's okay. They're good for $2 billion per launch, something like that. Then you've got the New Glenn and so on, magnificent vehicles for their purpose, and then you get to the small ones, which are going to be more likely mass produced. But you can produce the small ones for hundreds of thousands of dollars. Those are real numbers, right? Those are not fantasy numbers. Those are not theoretical sort of things. Those are real numbers if you produce enough of them. Next. So if you look at, everybody talks about dollars per kilogram. Bob mentioned it, and I think Starship's talking about $500 per kilogram. Right now, large launch is in the $7,500 to $2,500, depending on where you're at per kilogram. If you actually look at cumulative production, which is on the bottom of some of the smaller vehicles, say the small launcher is something like a Taurus class vehicle, and then the micro launchers are something more like the Vector H or the Vector R. You can actually get close to those numbers with enough production. So if the idea is true that we're launching hundreds a day, and I believe that to be the case, then ultimately this will be a very cost competitive side of this. And this is why there's billions of dollars of venture capital flowing into this particular market. It is probably an investment bubble, but it's not just an investment bubble. There's a real idea behind this. Next. So the manufacturing approach is really not that hard. If you're talking about hundreds a year on micro launch, it's a little bit like how Maserati went in the 60s from, Luigi would have his little Maserati here and he'd bring the parts. And by the time Luigi was done a month later, Maserati went out the door. It's kind of how big rockets are produced today, with a moving assembly line like some of our military systems. Cruise missiles are built this way. Hundreds a year doesn't take a huge amount of capital investment. So we're not talking about robotics and things like that. Really just simple Model T kinds of production. Next. So the other thing to think about is what's the infrastructure associated with a small launch. And so yesterday when I was at the Cape, I bumped into a Mercury, and it was about the size of some of these things we're talking about. So it was like Back to the Future sort of thing. And they launched these things from just a little stool, bolted it down with all the proper explosive bolts, and put the guys in the top. I mean, that's really kind of where the small launch industry goes back to, is we don't need extensive infrastructure. And so that may seem like a gimmick, but there's actually a real reason behind this, why this is important. Next. And this may seem strange, but how many of you have been to the cities and seen these little scooters where you can rent them and you drop them off? Yeah. So 2 years ago at this automotive conference in Germany I went to, the McKinsey guys got up and they said micromobility is going to be the fastest growing transportation segment in the world. And this year when I went back several weeks ago, they showed that it was indeed, and there was over 1 billion of these things deployed worldwide. There was even a guy from Congo who was running a micro-mobility startup in the Congo, right? And he was running all these cultural problems about, how do you really do this and how do you pay for it? And it turned out the biggest issue is if you fall over, nobody will call the ambulance because they're afraid they have to pay to send you to the hospital, so they let you die. So, their users got a vest that said, we'll pay, for the transportation to the hospital. But the reason this has taken off is really three things. One, no new infrastructure was needed. Number two, the supply chain existed. Number three, there was a lot of capital that came into it to make it happen. So now you can start to see the parallels between small launch and this. Once we reach that tipping point, you'll see small launch just take off like crazy. Next. So here's just showing the e-scooters and how they've gone crazy in adoption rate, and just as a proof of concept. Next. So once this happens, we'll create a new transportation model where we're doing rocket launches by hundreds a year rather than tens of flights per year. Next. And I have no doubt the Starship's going to fly. I have no doubt that it'll be a revolutionary effect. Next. But I think this will be our pedestrian transportation into space, as it turns out. Next. Thank you very much. Time for a question? Yes. Okay.
Hi, my name's Doug. SpaceX, I think they just did a filing where now they want to put like 30,000 Starlink satellites in orbit over who knows how much time. So I guess I'm wondering, from a capability standpoint, I know obviously the CubeSats, the microsatellites are able to do much more, but it seems as though, at least in the case of SpaceX, looks like they're looking at about 225 kilograms, far more than microsatellite, as a sweet point for their capabilities. So can you talk about, I guess I'm concerned microsatellites could fulfill a educational role where it's not so much money making but giving college students experience. So could you talk about capabilities? Thanks.
Yeah, so with respect to Starlink, that's a communication system, and when you get in, at least with technology is now, communication is all about power, and power beamed, power received, and power generated. So that all tends to be heavy. So all the communication satellites, OneWeb, they're all the same thing, right? They all weigh about the same, as it turns out. Iridium was about 700, 900 kilograms, something like that. So these are coming down. So as technology goes, they get lighter. They're clearly lighter than they used to be. When you talk about CubeSats, I was of the opinion that they were just toys for educational sorts of things, but so I built something called LightSail 1 and 2. Bill Nye didn't invent solar sailing, by the way. We built that separately with some guys that did it out of a CubeSat. And what I've discovered as well, I'm an investor in probably 6 different space startups. There's an immense amount of things you can do with CubeSat-ish kinds of things. And when you think about CubeSats, one U is just sort of that big, 10 centimeters cubed. And what we're starting to find out is form factors of 12 and 16. You can do some pretty amazing things. If any of you were watching the Twitter feeds or news from the Hurricane Dorian when it was over the Bahamas, there was something called ISI satellite that was taking SAR images in real time through the clouds of the island, showing where all the water was, what was submerged, what was going on, how deep the water was. That was a CubeSat. That was a company I invested in out of Finland about 6 years ago, and they were doing that for $1 million a copy, whereas the ones we built for the U.S. government were closer to $1 billion a copy. So I have no doubt that just like computers, I remember my first computer at home was an 8088, right? I did my thesis on it, and I would have never imagined what we could do with these, and that's exactly what's going to happen in space. And what you need is the power of the entrepreneurs and the power of the people who think about these things, and the next generation of kids. I mean, my kids pick these things up and they know how to use them, right? Like they come out of the womb and they know how to use these things. That's a whole new generation of thinking that I don't relate to. I relate to nuts and bolts and things like that. But we've got to make the space industry into something that kind of innovation can create value out of. And I'm confident it'll happen. And we just continue to see the CubeSats morph and change over time. So I'm pretty confident that you'll see that continue to be a pretty strong industry.
We have time for one more question. Sorry. Last question.
Hi. When you talk about these CubeSats and everything, all I can see in my mind is space junk. How do you keep from the big guys running into these little things?
Great question, and I've answered this one many times. So one of the problems with rideshare, which is where you put a bunch of these CubeSats on a big rocket, is you're going somewhere where somebody else wants to go, and usually that somebody else is a big satellite that wants to go in an orbit, like sun synchronous, for example, for imaging, and that's one of the most popular orbits for CubeSats. And that's usually high enough that the atmosphere doesn't bring it down for more than 100 years. So if you're putting CubeSats in that orbit, they become debris, right? One man's satellite is another man's debris. And so the other problem is the further they're away, the smaller the radar cross-section, so they're harder to track and so on. The last SpaceX flight, ISI X2 flew on it as well. It came off, they didn't lose track of it, but there were about 20 some odd satellites in the middle that we just lost track of them, and the owners couldn't communicate with them because they didn't know which one was which. So this is part of the problem with rideshare, right, which is why I think rideshare won't last. So if you had the ability to rapidly replace these things, like if we did have hundreds of launches a year and they were cheap, then it's a whole lot easier prospect and a better prospect to follow the model of your iPhone, which is when you get a new model, you just throw it away and you get a new one. So if you fly them in a low enough altitude, the Earth's atmosphere will recapture it in years, and you don't worry about the replacement. That's part of the life cycle of it, and that's exactly where this will have to go once you get into a lot more satellites in space. And really, the biggest problem is in these higher orbits where you don't have a short lifetime, and you have these kinds of collisions. So that's why the other reason I believe that small launch will actually be de facto a way to do it, because of this collision issue. All right, thank you.